Welcome to this brand new educational series. I am very excited to be presenting a comprehensive program and an in-depth educational series that focuses specifically on the essential skills of effective problem solving in your daily life. In this comprehensive course, I will be using the C++ programming language specifically, guiding you all the way from the absolute beginner level through to the most advanced professional levels. To begin our journey together, we first want to start with something fundamental that will set the stage for everything else we are going to learn in the upcoming lessons. The system is known as FluShort. FluShort is a comprehensive and structured learning methodology designed for absolute beginners in programming. And that is exactly what I am specifically targeting throughout this educational video series for students. FluShort makes it much easier for you to build complex programming logic as a person when you want to think logically, helping you organize your thoughts with clear and consistent logic. And with perfectly sound logic, you will want to use a tool, this educational tool that has become the widely accepted standard in learning programming at the very beginning stages is called a flowchart. Of course, in this introductory video, right here at the very start of our new series, as you can clearly see on the screen, we are beginning with Problem Solving Level 1. This is the first lesson where we will tackle the easiest possible problem or the simplest program imaginable. We want to work through it together and really think about it logically from the ground up. And that specific task is the fundamental addition of two different numbers. The specific task we are looking at today is this. Draw a complete and logical flowchart to find the sum of two different numbers. How exactly do we perform this mathematical operation in a step-by-step visual format? Throughout the coming minutes of this video, we are going to provide you with a very detailed and comprehensive explanation of how to achieve this, accompanied by a clear practical example so that the entire concept becomes perfectly clear to everyone watching. So, let us begin to learn the art of logical problem solving together right now, and a very warm welcome to this ongoing educational series designed for your success. As you can see here, within this specific software, this particular section is referred to as flowcharts, or the complete flowcharts. If you look closely, you will notice that the sequence starts with start and ends with end. This visual diagram represents the complete flowchart for the addition of two numbers program, which performs the calculation. Now let's take a moment to think carefully about the specific name of each shape so that the overall picture becomes much clearer in your mind. You will notice that the labels start and end represent the very beginning and the final conclusion of the entire program. We traditionally call these the start and end points of the flowchart, and you can see that their physical shape is a smooth oval. So, in any standard flowchart, we always begin the process with this oval shape at the very start of the program, and we must end with it as well to show completion. You can see right here in this next section, it is clearly called read, which is another vital part of our structure. What this essentially means for us is that we now understand from this section here that it is a dedicated area for entering a specific number, typing in some text, or providing a data value. This geometric shape is widely recognized in the world of flowcharts as the parallelogram, and it is consistently utilized to represent the standard input operation whenever it appears. Now, let's move on to the actual calculation process, which takes place deep inside the central processing unit of the computer. For this specific calculation process, we always represent it visually with a regular rectangle shape just like this one. And for the output process, we represent it with this shape. So this is the foundational flowchart from which every single computer program is ultimately made, regardless of exactly how highly significant or deeply complex it is as a flowchart. I am speaking to you here now, not as an algorithm. I haven't written a single line of code yet, but I'm explaining the logical way a particular computer program works, the algorithms, how to solve it, what its internal structure is, exactly how it starts and how it finally ends. So to provide a brief summary. As you remember, for our very first algorithm example, we specifically requested a method to add two numbers together in C++. or any other programming language that you might use in your projects. So, how exactly do we execute this specific program? Let's take a close look and follow this detailed flowchart step by step to understand the programming logic behind adding these two numbers together. To start with, we can clearly notice that the program is currently paused and stops at the start indicator. When you manually run and activate the entire program and then perform a run operation, the system will begin to work and successfully enter the start mode. This specific start point of algorithm indicates the initial state of the process. The program has now completed its setup phase and is now ready to execute your commands. Sequentially meaning in a logical sequence, and as you can clearly see here, this represents the device's internal memory, or perhaps a screen displaying the complex solution algorithms. At this point, it becomes clear that the program has started, the program has truly begun. So, to calculate these two numbers, what do we need to do? Of course, the computer doesn't understand what we want until we give it clear instructions. So in this specific case, we will tell it, "Computer, we are going to input a number for you, the very first number, and we want you to read it carefully." It will then respond to you. All right, please give me the appropriate algorithm for this, and the appropriate algorithm is read A. The A here is simply a label for the variable. It is named after... Why don't we go ahead and give it a proper name right now? In the field of computer programming, a specific storage location in memory is usually called a variable. Essentially, a variable is a unique name that holds a particular value, all of which is securely stored within the computer's RAM. I truly hope that this mental picture is clear for you to visualize. I personally understood it in this exact way when I first started learning. So whenever you tell the computer system to read the value of A, you are actually interacting with this specific variable. A will carry its own specific name. A will be a variable, and we refer to it as a variable because its value is expected to change. Maybe we'll decide to add 1 to it, maybe we'll add 500, or maybe we'll add 1,000 depending on the specific value. That is the reason why we called it a variable. It is a name that fits its actual function. So in this case, we'll say, the next step is to read one. Now what do you notice here? Read the first variable, which is read A. Following this specific procedure, the computer system prompts the user to input a numerical value, and once that value is provided, the system identifies a specific memory location, which is commonly referred to as A in practical programming terms, to safely store this information for later use. This is precisely what the user needs to enter into the system at this stage of the process. For example, we are going to go ahead and press this specific number on the keypad right here, just to show you how it works, for instance. Okay, now that we have successfully completed that part, we can move forward and press the very first item displayed on the screen. The next step in this sequence now, in order to successfully add these two different numbers together, is that we are going to need to input the second number into the required field as well. Please make sure you are following along very closely with each of these individual steps to ensure the calculation is performed correctly and without any errors in the final result, as this is crucial for the system to process the data accurately. Now, let's move on to the next step. Now let's take a look at part B. Here we have the exact same model that we used in the previous exercise. In this step, we are going to ask the user for a second number and then carefully place it into a brand new designated memory location which we have called B. For example, let's consider how this works in practice. We will enter this number. For example, now, looking right here at the screen, as you can see, we are moving into what is known as the business area of the layout. What you need to do next is carefully take all the specific colors from exercise A and the various colors from exercise B that we worked on previously, then you will combine them together thoroughly. Once that is done, start adding several new data points directly into this business area. And as you look at the sum range indicated right here, this is exactly how it should appear. Right here on the surface of the CPU, all of the mathematical operations are being calculated. In this specific area, the entire program is being executed. First, it will calculate the value stored in A, then it will calculate the value stored in B, and finally it will assign those results to a new variable called sum. Inside this sum variable, there will be the total value of A plus B. As you can clearly see here on the screen, the value of A was 25 and the value of B was 56, so the final sum equals 25 plus 56. Right now, we are currently at the CPU stage. We are still working within the CPU stage, inside the processor itself. We have not yet actually displayed any of this information to the user's screen. So the question is, do we want to display it to the user's screen now? Yes, that's what we want in the program. Print the result of adding two numbers. Right now. Here, the print sum command has finally appeared on the screen. As you can clearly see right here, the total sum is exactly equal to 81. Here, the addition operation was clearly displayed for the user on the screen. Once that has finished, the program is still running the last step, which is the final step of completely terminating the program execution. At this stage of the process, we can proceed by saying next step. The program has now concluded its execution and has ended quite successfully. In this specific instance, we have actually managed to complete every part of this arithmetic operation perfectly, and what you see here are the comprehensive and detailed steps used for solving the problem. The start of the program. Taking the value from the user, the first value, then taking another value from the user, the second value, then performing the calculation by adding them all together, and subsequently storing that calculated result in a specific variable called sum, then proceeding to display and print out this final result of the addition, this result is called the sum. After that, we can finally end the execution of the program. This is definitely one of the simplest and most basic algorithms available, and it is the specific algorithm we are focusing on in this particular video for this entire educational series. By the way, we will talk about algorithms only through flowcharts. We will not get into coding. But this is just so we can understand the logic of solving the problem, to make it easier for you to grasp the logic of problem solving. Take a piece of paper and a pen and draw. By drawing these shapes and adjusting these values, you will gradually develop your logical thinking. And in the upcoming videos, we will dive deeper and deeper into more complex algorithms, step by step and gradually, so that together we can build up this series. Develop logical thinking in a structured and gradual way. I really hope this video was helpful to you. And if you have any further questions, I would be more than happy to help you out. I will receive it in the comment section below. There will also be some helpful resources in the video description below. Check them out. They will be very suitable for your needs. And I might also put a link to this tutorial program at the bottom of the video. Thank you so much for watching, and stay tuned for our exciting upcoming videos. Don't forget to click the notification bell button and follow us for more new educational lessons. Thank you for following along, and we'll see you in upcoming videos. Goodbye.